All right, so this is how to draw ray diagrams with curved mirrors. I've already gone and set this up. I have a focus at 10 centimeters away from my mirror. This is a concave mirror. My center of curvature is double my focal length away. And then I've got my object at 40 centimeters and it's 10 centimeters tall. If you do this correctly, you should be able to actually measure to find out your answers. However, it's not always perfect, so that's why we're going to do the math at the end. To get an image to show up, you need two rays to cross. We'll always draw three rays just in case you screw one of them up. First ray is easy. This is the one where we found out how to find the focus. We draw in parallel rays to the principal axis. Then we take that. When it hits the mirror, it's going to reflect back through the focus. Hopefully you guys, when you're doing this, are using a straight edge. Otherwise, you're not going to get the best images. We know these are going to be real because our rays should cross. My second one, and this one's the easiest one, is going through the center of curvature. When it goes in through the center of curvature, it's going to hit the mirror and reflect straight back. So right now, we should know that our image is right here. Our last one is the opposite of the first one. Instead of coming in parallel and going back through the focus, this one goes in through the focus and comes back parallel. So I'll line up the tip of the image, have it go through the focus, it hits the mirror, and it comes back parallel. And if you do it right, all three of them should come together. If they don't, then you know one of them's wrong. So as a result, my image should look something like that. Down here, we'll do one for the convex mirror. We should get a virtual image for this one. Notice on the first one, since it shows up where the rays actually cross, it's a real image. It's inverted, and it's smaller. Hopefully when we do the math, it looks like that. When we get done with this one, we'll do the math for both of them. The rays are exactly the same on a convex lens. The only difference now is that our focus is on the back side of our mirror. So I'll come in parallel. And now what I'm going to do is I'm going to aim at the focus, but no real ray actually makes it to the focus. So I'm going to draw this arrow away from it. And I'm going to give a dotted line behind. We should get a virtual image behind the mirror. Next, what I'm going to do is I'm going to aim at the center of curvature. This is the easy one. You just go in a straight line, it hits, comes straight back. This one can be a little harder if you've got a giant board like I've got to keep it balanced, but boom, hits the mirror, reflects back, and then we'll get a dotted line going all the way to the center of curvature. That's pretty close. As long as the lines are pretty close when you're done, you're Gucci. Finally, the one that aims at the focus and comes back parallel. Aiming at the focus, when I hit the mirror, reflects off parallel to the principal axis. And now mine may not be perfect, but you'll get the idea. Dotted lines backwards. And notice when you look at these rays, they're divergent, which is why you get an imaginary image, a virtual image back here. So in this case, we should end up with one that is virtual, smaller, and upright. Now let's go ahead and solve the equations to figure out where our objects are. So 1 over my focal length is equal to 1 over my image distance plus 1 over my object distance. We know these two. My focal length is 10. My image distance is what I'm trying to find, and my object distance was 40. These are all in terms of centimeters, so now I do 1 over 10 minus 1 over 40, and then I take an inverse of my answer. And when I do it, I get an image distance of 13.3 centimeters. If I were to take my ruler, and you can see it's a little bit past 10. If I were to put this up, hey, that's not bad. It's right around 13, so that's pretty good. Now for magnification and my object height. So magnification equals negative SI over SO, which is equal to HI over HO. So since I have SI over SO is equal to negative, here I'll do it in a separate line here. Magnification equals minus SI over SO. That equals my image distance, which is 13.3. I'll put that negative out in front, and my object distance is 40. Based on that, since it's going to be negative, that tells me it's going to be inverted. So 13.33 divided by 40. I get that my magnification is 1/3. So I should be 1/3, and since it's negative, it's inverted. If I take a look, I should be at about 3 centimeters tall here. I'll measure from 20, and look at that, right about to 23. So that's pretty good. If I wanted to find the height, I would just take that 1/3, multiply it by the object height, same idea. Now let's do the same down here. The only difference is 1 over f, we still use the same equation, SI plus SO. I bet I'm going to end up with an SI that is negative. So my focal length here is -10 because it's on the back side. 1 over SI plus 1 over 40. When I solve for SI, let me plug all that in right here. So I have negative 1 over 10 minus 1 over 40. Take my inverse, and when I do that, I get -8 centimeters for my object distance. Let's go ahead, measure it. Look at that, it's a little bit inside of F. I'll measure from 60 here. What do you know, right at 68. That's pretty good. Do the same thing for magnification. Magnification equals minus SI over SO. My image distance is -8, so that's -8. We should end up with something positive that tells us it's upright. SO is 40 again. So when I plug that in, 8 over 40, I get 0.2, so 1/5. Positive 1/5. So what it should be is about 2 centimeters high. What do you know? That looks about 2 centimeters. And it's upright because I get a positive number. And that's all you need to know to do these. One thing to be careful of is when you get your object at the focal length, because when the object is at the focal length, you're not going to be able to draw some of the lines. And then be very careful once an object gets inside of the focal length. Those may be a little tricky. Feel free to email me and ask me questions if you've got them.